Hey guys, Mr. Ground for 14.1 day 2 shift of sine and cosine graphs. So we've got sine and cosine graphs down, hopefully. Now we're going to move them up, down, and then side to side as well. So starting out with our transformation rules. Vertical shift looks like this. If we've got sine or cosine of x and you are doing plus k, and there's no parentheses involved, right? If it is plus k, this is a shift up. If it's minus k, this is a shift down. It's no different from when we went over transformations earlier in the year. Then phase shifts, these are your horizontal shifts, right? So this we could say is your horizontal. Same idea there. Now in trig, we've got some special terminology, and a horizontal shift is known as a phase shift, and that's what we're going to refer to it as going forward. So now if we have, let's say, cosine x plus h, where it's in parentheses, remember vertical visitors if it's outside the home, horizontal homies if it's in the home, the parentheses are the home. So if it's in those parentheses, it's horizontal. And then with trig, horizontal is phase shift. I know, it's confusing. Plus h, remember, is sort of the opposite of what you would think, right? You're thinking horizontal plus should be moving to the right, but it's actually to the left. So this is a phase shift to the left, and minus h is then a phase shift to the right. So it's sort of like logical up here, and then it's sort of against your intuition down here. All right, so let's apply some of these rules. You're going to be, one, identifying them. Like just looking at the equation, can you tell me is it up, down, left, right, how much? Also, can you graph one that has a transformation? Could you look at a graph and identify what the transformation is? Could you look at the graph and identify what the equation should be to match that transformed graph? Okay, so something like this, cosine of x plus 2. So looking at this, the plus 2, there's no parentheses, so I know that this is a vertical shift of up 2. We'll fill in all of this stuff in a little bit. When I'm graphing this, I need to now think about my scale a little bit. So notice I made my x-axis a little bit lower from the middle, so I had some room to move up. And let's see, what should I count by? Will this work? Yes. I think that ought to work. Now let's start out with our important points of an untransformed cosine graph. Oh, let's get our horizontal scale in here. Right, so we've got a consistent scale. We're counting by the same amount. If we put in our important points, I'm just going to put them in here as dots and not fill them in, because I don't want to graph cosine. I want to graph cosine of x plus 2, right? Now, if I think about like starting with those 5 points, what does this look like if I shift each of them up 2? Well, that's all I need to do really, is take this point and move it up 2. So from 1 up to 3. Then from this one, from 0 up to 2. From -1 up to +1. So a horizontal or a vertical distance of 2 for each of these. This one moves up 2. And then this one moves up 2. And now I have 5 important points graphed of my transformed, my vertically shifted cosine graph. Okay, midline. This midline would normally have been the x-axis. That also gets shifted up 2. So this one, the midline, goes right through the middle like here. And some teachers, sometimes we do ask that you graph the midline as well if it's not on the x-axis. What we're going to be asking you to do is identify the equation of that midline. Remember, it's not just 2, it's y equals 2. It's an equation of a line. All right, the amplitude. Amplitude hasn't changed. The height from the midline to the top is still 1. That's a distance of 1. From the midline to the bottom is still a vertical distance of 1. So our amplitude is 1. And our period hasn't changed either. It starts at 0, ends at 360. That's a horizontal distance of 360. All right, so really for today, amplitude and period aren't going to change. Midline may or may not change depending on where we're shifting it. All right, let's take a look at one that's going downward. I'm just going to leave that 1 and 360 in because these shifts are not going to change that. All right, so sine of x minus 1.5. We're going to deal with some decimals, some fractions and stuff like that. So this is a vertical shift. It is down 1.5. When we're graphing this, then I might want to bump my axis up a little bit to give myself room to shift it down. 90, 180, 270, 360. All right, what should I count by? I want to count by an even number of blocks so that I can easily split that in half, right? I'm shifting down 1.5, so if I count by 4s, that means that 1.5, negative 1.5 is right here. So that's a good scale for this one. Okay. My original 5 important points. Origin, up to 1, down to 0, down to negative 1, back up to 0. Now let's shift each of those down 1.5. So this, if it goes down 1.5, is right here. This one, if it goes down 1.5, like 1 and then 2 more squares for 0.5. The zeros are kind of easy. Then this one goes down 1.5. And this one goes down 1.5. Get rid of some of these dots so I don't accidentally connect the wrong ones. Now I've got my 5 important points graphed. Let's connect it with a nice smooth line. And let's see, amplitude didn't change, period didn't change. Midline goes right through the middle right here. And that is an equation of y equals negative 1.5. It always ends up matching your vertical shift, right? It always ends up matching whatever k is, right? So if this is minus 1.5, it's y equals negative 1.5 is how that works. All right, let's take a look at some horizontal shifts and some phase shifts. So now we've got some parentheses involved. We've got some horizontal homies. Let's see. Amplitude and period do not change with a horizontal shift again, because moving these side to side isn't going to change, or up or down, isn't going to change their total height above the midline for the amplitude. It's not going to change how often they repeat either. All right, so let's let's think about the transformation first before we set the scale. Let's visually, verbally, say what this is. Plus is to the left, so this is a phase shift. Left 90. All right, it's moving to the left 90. So I know it's going to start further to the left. I might want to move my vertical axis a little bit to the right. All right. I'm not shifting it up and down, so I'll put my x-axis right in the middle again. Now, I know that I'm shifting it to the left 90 degrees. So I'm going to start my scale to the left of the origin by 90. I'm going to make sure that I can fit that on the graph. Okay? Let's see. Height is going to be from 1 to negative 1 because we haven't shifted it up or down at all. If we start out with our important points and then we shift them to all to the left, we should get a good graph. Okay, so there's my 5 important points. I'm going to take each of those points and I'm going to move it to the left 90 degrees, and I'm going to try to remember to erase these as I go. Otherwise, you can end up with a lot of extra dots on your graph. So this one moves to the left 90. This one moves to the left 90. This one moves to the left 90. And this one moves to the left 90. So now, if I connect all of these, there's my cosine graph, slightly offset now to the left, offset to the left by 90 degrees. All right, now the last thing on here is the midline. I haven't filled that in yet. Think about, does the midline change if you shift to the left or the right? It doesn't. That x-axis only changes if you move up or down, right? So if I move it this way or this way, it's still the same line, so it's still y equals 0. There's no plus on the outside here, right? If it was plus 3 on the outside, it would be y equals 3, but it's not, so that midline remains unchanged. All right, that'll save us some time for this one. We know that the period doesn't change with a horizontal shift. We know the amplitude doesn't change with a horizontal shift, and we know that the midline also doesn't change if we shift horizontally. So let's take a look at this one. All right, sine of x minus 30. Minus on the inside is going to be a phase shift to the right, 30 degrees. So now I'm shifting to the right. Let's give myself a little more space for myself. Now I do want to think about the numbers I'm counting by. With 90, with like the important points are at intervals of 90, which is kind of nice for the most part, because you can divide it, like you can either split it in 2 if you have to count by 45s, you can split it in 3 if you have to count by 30s or something like that. So because I'm shifting to the right 30, I want to make sure that I've got 3 spaces here when I do my my important points, when I'm counting by 90s. Because if it's 3 spaces to get from 0 to 90, well then 30 is going to be one of those spaces. And that's going to be really nice when I'm shifting everything to the right by 30 degrees. So think about your horizontal scales a little bit when you're doing these. Okay, we'll start out with our important points. And if you do this enough, you don't really need to do the important points, but it's nice to start there, because now I can take all of those and I can just do this. Move it to the right 30, which, how I have defined my scale, is 1 square to the right. So each of these just scoots over 1 square to the right. And we go like this. Oops, try that again. Sometimes it's best if I just turn my back to the camera so I can square up my shoulders to the board. It's kind of like in football. You want to square up your shoulders to your opponent. Same thing. You want to square your shoulders to the board or your piece of paper when you're doing a graph. All right, that's it for ups, downs, lefts, and rights. Let your teachers know if you have any questions, and have a great day.